Hey, hello, and welcome to today's GFG problem of the day. Hope you're doing well. So let's see today's problem. Toeplitz matrix. So what the problem is saying is a Toeplitz matrix is a matrix in which each descending diagonal from left to right is constant. That is, all the elements are same in the given diagonal. Given a rectangular matrix mat, your task is to complete the function is Toeplitz, which returns 1 if the matrix is Toeplitz, otherwise it returns 0. So what the problem is saying is each diagonal, right, starting from left to right, that is descending. Okay, see, if you see, all the elements are same, right, in the diagonal. Here also, if you see, descending from left to right, okay, that is from top to bottom. Okay, so all the elements in the diagonals are same. So if such is the case, then we can say that it is a Toeplitz matrix and we have to return true. Okay, so this is the ask. Okay, now how we'll proceed? Also, if you see, if the time complexity, right, the time complexity is O of n into m. That is O of n square, and space complexity is O of 1. Okay, so how to solve this problem? Okay, so what we'll do is first we'll cover this rectangle. Okay, which rectangle? We'll cover this rectangle. We'll check whether the diagonal, right, all the diagonals which fall in this triangle, are okay, have the same element. So we'll start here with here, right? So we'll start with this element, right? What we'll do is we will have a constant that is 0th row. Okay, 0th row, and we'll just keep on changing the j. Okay, just keep on changing the j. So let me quickly explain, right? So we'll start with here, j equal to 0 and I equal to 0. Okay, so we'll start with here and we'll increment I and j both at the same time. Okay, I and j both at the same time, so that we'll traverse this diagonal and we'll check whether this diagonal has all the same elements. Okay, if this is done, if it is not the case, simply we'll return false. If the elements are different, we'll simply return false. If it is true, then we will still keep I as 0 and we'll increment j. Okay, once we are done, we have incremented j. Now we'll check for this particular diagonal. We increment I and j together and we'll check for this diagonal. Okay, likewise for this also, I will be same. Okay, and j will be incremented. Since this is a single element, we can say that it's a Toeplitz. Okay, it follows the property of Toeplitz. Okay, now this is done. This triangle is done. Now what we'll do, we will traverse this particular triangle. Okay, this particular triangle. Once the upper triangle is done, now we will traverse this lower triangle. Okay, we'll traverse this lower triangle. Okay, so this one again here, this time this column is going to be constant, that is 0. Okay, and we are going to change the row, right? So we'll first start with I equal to 0 and j equal to 0, right? And again we'll check for this particular diagonal. Again, this is a repeat process, but yes, for this diagonal it is going to be the same. Okay, so here we check this, right? And then what we do, this is same. Then we proceed ahead, we increment I, right? J will keep it at 0 only, constant. Okay, so let me code. Let me first write for this particular, let me code for this particular triangle, the upper triangle. Okay, so let's quickly okay, so what I'm going to do is first I'm going to show you the Java code followed by C++. Okay, so what we want is we want the length. Okay, the row length. So how it will be? Okay, then we want the column length, right? So we have our n and m. Okay, so now what we'll do, we'll simply okay, so what we're going to do, we'll simply int j equal to 0, j less than m. Okay, we are going to traverse all the columns, right? The column will be variable basically, plus j, right? And what we're going to do, if is Toeplitz util, right? Toeplitz util, what we're going to pass mat, then 0, we are going to keep the row as constant, as I said, right, in this example, right? This particular upper triangle will keep this as constant. We'll keep on changing the j, right? We'll keep on changing the j. So we are going to keep the row as constant. Okay, row as constant, then j is going to change, keep on changing. You're passing the row and column length. Okay, if it is false, then simply return false because it is not following the property of Toeplitz. Now let me quickly code Toeplitz util. Okay, this will return as boolean is Toeplitz util. We'll have our mat, then int I, int j, int n, int m. Okay, and we'll take our first reference value. Okay, the reference value will be mat of I and j. So what is this reference value? Let me quickly explain this. So this first value, right? We are executing this particular triangle, right? So this first value we're taking as a reference, right? So we took this as a reference. Okay, now what we're going to do? We are going to have a while loop, right? We'll increment I. Okay, we'll increment I. Okay, and also we'll check I should be less than n, and sorry, we'll do this operation incrementing and this, right? And incrementing j, which will be less than m. Okay, if such is the case, so what we're going to do, if mat of ij, right? Mat of ij, if it is not equal to reference, right? If it is not equal to reference, then simply we are going to return false, right? So what we're doing here is, we have incremented I and j both here, right? Both I and j. Where did we increment? In the while loop itself, in this while condition, right? And we are checking with the reference. So what is the reference? The reference we have is here, right? And this we are checking the value with, right? So if both are not same, then you have to return false. Else we'll increment, we'll check for the next element with the reference, right? If it is true, then simply we'll return true here, right? So this upper triangle is processed if you see, right? This upper triangle is processed, right? So here what we are doing here is we are incrementing j. So okay, j. So now once we are done with this particular column, right? For example, 6, 7, 8, right? 6, 7, 8. Sorry. Then we have 4, 6, 7, 1, 4, 6. So we are done processing this diagonal, right? Now we'll process this one. So how? We'll increment j now, right? I will start from 0 only. I will always start from 0 only. So we are incrementing j now, right? So in this way, we are processing the upper triangle. Okay, we have processed this. Now we'll process this lower triangle. Okay, now we'll process this lower triangle. So how we'll do that? So simply we'll now keep j, we'll start with j as 0, that is column as 0, but we'll increment I, right? As to process the lower triangle. All right, and it should end with n, I, right? This will be I and this will be 0. So in this way, we'll process with the lower triangle, right? We are processing the lower triangle. Okay. So same, it is going to be Toeplitz util, right? So this will make sure that our lower triangle, okay, that upper and lower triangle is checking the Toeplitz property. Okay. So finally, if everything is good, we'll return true. That is the complete matrix is following the Toeplitz property. Let me quickly compile this. Okay. Okay, the test cases have been executed. Thanks for watching. Please subscribe to my channel because a lot of efforts goes into solving and preparing this video. Thank you so much. Let me quickly show you the C++ code as well. Okay. So here it's almost the same, right? We have vector of vector here, right? So we are taking size n and then m, right? And then following the same process in the upper triangle, checking for the upper triangle and then checking for the lower triangle. If everything is good, finally we return true. So this is the code, okay, C++ code. Thanks for watching. Please subscribe to my channel. Have a happy, healthy and a great day. Thank you so much.